Hey, welcome back, everybody. We are going to talk about trig at some random angles today, and we're going to talk about inverse trig functions, which are going to be pretty tight. So for the random angles, the trig at any angle, this is very similar to our unit circle, except now instead of being on a circle that has a radius of 1, what they're going to do is they're going to give you a random angle. So it'll be like this. And they're going to tell you the endpoint of this, but it's not going to, this thing won't be 1 anymore. It'll be like 5 or 10 or something like that. And then they're just asking you to set up your trig functions. It's going to be pretty easy. Inverse trig functions are also easy, but there's some like nuance that I want to talk about just because often what happens is students think trig functions work one way and they don't. So I just want to make sure you understand what you're doing. So hopefully today's examples are pretty easy and straightforward. All right, cool, let's go. So let's start with finding the exact value of all your trig functions. And I'm going to take this thing, I'm going to move it around to like each of these. Put that back together. Group. Okay. I'm going to take this thing and move it around just because I'm going to need this space here for drawing, but you'll figure it out. Okay. So let's look at this first angle right here. We want to figure out what are our trig ratios for all of these. They don't tell us the angle, and unfortunately, the ordered pair at the end is not on the unit circle. The fact that this is 3, 4, that means they've gone 1, 2, 3 that way, 1, 2, 3, 4 that way. A unit circle on this graph would look like that. So we're like way outside the unit circle. So we can't use our knowledge of the unit circle that we got from last lesson to do this. We have to use our knowledge of Pythagorean theorem and then how to set up trig ratios based on just angles. Okay, so of course T is theta. It's just hard for me to write thetas. You'll see them later, but you know. So all right, let's do this first one. We want to figure out what are sine, cosine, tangent, cosecant, secant, cotangent for this angle. Let's break up and figure out what we know first. Let me make this a little bit narrower. Okay. So this ordered pair right here tells us x and y. That's telling us x right here, that's how wide this is. And it's telling us how far up that ordered pair is from the x-axis. It's 4. So if we look at it this way, we get a right triangle. So what we need to do is we need to find our hypotenuse by doing Pythagorean theorem. And then once we know all 3 sides, if this is theta, here's our opposite side. Oops, sorry. It's been a long day. Here's our opposite side. Here's our adjacent side, and then here's our hypotenuse. Once we know those 3, then it's really easy to set up all these fractions. Okay, there are 2 that we could do right now. Because we know the opposite side and the adjacent side before doing the Pythagorean theorem, we could fill out the trig function that only depends on the opposite and adjacent side, which are tangent and cotangent. So tangent is equal to sine over cosine, and I'm omitting the thetas here, or y over x. So also opposite over adjacent. So there's 3 different ways we can think about tangent now. So our opposite side is 4, our adjacent side is 3, so this would be 4 over 3. And then cotangent is the reciprocal of this, meaning you just flip it upside down. So this would be 3 over 4. All right. To get our last 4, we need to know what the hypotenuse is. And to get our hypotenuse, we're going to use the Pythagorean theorem. So our 2 legs are 3 and 4. That's our A and our B in Pythagorean theorem. So it's going to be 3 squared plus 4 squared equals the hypotenuse squared. I'll just put C squared. This is 9 plus 16, c squared. This is 25 equals c squared. And then to get c, we take a square root. So c is 5. So our hypotenuse is going to be 5. Cool. Now that we have that missing side, we can go ahead and fill in the rest of these. Sine is opposite over hypotenuse, so 4 over 5. Cosine is adjacent over hypotenuse, so 3 over 5. Cosecant is the reciprocal of sine, so this is going to be 5 over 4. And then secant is the reciprocal of cosine, so 5 over 3. And there you go. There's your 5, or your 6. I probably won't ask you for all 6 on one problem. What'll happen is I'll give you this thing, and then I'll say find secant, or find sine. And you'll just have to do like 5 or 6 different ones. But that's fine. Practice is good for you. All right. Let's go look at our next one. Okay, so now we're going to look at this one. I'm actually not going to move it. I'm going to leave it where it's at so I still have workspace. All right, so the angle we are looking at is this angle right here. And you're going to go, wait a second. I can't, that's not a right triangle. What the heck? Okay, but we can turn this into a right triangle by looking at just the x and the y. So our x is -7. The way we're going to interpret that is we're going to interpret that as 7 left. I understand that you can't have a negative length, but we can have a length of 7 in the negative direction. So we're going to make our triangle right here because we just need to use these two values to find that missing hypotenuse right there. Okay. So this length here, it's 7 long, but we're going to put negative because we're in the negative x direction. This length here is 1, and it's positive because we're going up. So now we're going to try and find our hypotenuse, and then we'll fill in our 6 trig functions. What's really nice about the Pythagorean theorem is if we plug in these two numbers, even with the negative, we can have -7 squared plus 1 squared equals c squared. If you square a negative number, that's -7 times -7. A negative times a negative becomes positive, and the negative kind of goes away here so that you still get the correct answer for your hypotenuse. The negative can't screw it up because squaring things gets rid of negatives. So we have c squared equals 49 plus 1, which is 50. So that's c squared. Take a square root. So here, you don't know the square root of 50, but you should simplify this into its radical form, or maybe its mixed radical form. For 50, you could factor this to 25 and 2. So if we had 25 times 2, you can take the square root of 25, right? The square root of 25 is 5. And then we can't take the square root of 2, so the 2 stays inside the radical. So c is 5 radical 2. That's what radical 50 simplifies to. If that's too scary for you, or you think you're going to mess that up, you can always type this thing into a calculator, and it'll simplify it for you. But it's nice to know how to do it yourself, right? You don't want to have to ask your mom to tie your shoes for your whole life. But you know, your calculator can do this. Just make sure you have the right kind of calculator. Some calculators won't. I think the ones we use in my class do, though. All right, so c is 5 radical 2. So let's put that over here. 5 radical 2. Now we're going to fill out our 6 trig functions. Is this still skinny? Yep. Let's make it even skinnier. Okay. So for sine, this is opposite over hypotenuse. And now, what is opposite? Okay, so opposite, we're going to talk about opposite just always being y. Yeah. Right? Because sine is y. Sine equals y. Sine is the y. It's always going to be the up, down. Okay. So it's going to be 1 over 5 radical 2. Okay, we can't leave it like that though because we have a radical in the bottom. So the way we want to rationalize this is we're going to multiply by the radical on the top and the bottom. So what happens on the bottom is radical 2 times radical 2 can be written as radical 2 squared, and they just cancel out and it becomes 2. So the bottom turns into 5 times 2, which is 10. Okay, so the bottom is 10, and then 1 times radical 2 is radical 2. So instead of writing 1 over 5 radical 2, we're going to have to write it as radical 2 over 10. Okay. Now, if we look at secant, if you try and flip this, you're going to get the same problem you just had. So secant, it's nice to know that secant is hypotenuse over opposite. If we go back to our original triangle here, our hypotenuse is 5 radical 2 over 1. So it's just 5 radical 2. There you go. And that saves you from having to like re-rationalize this. Same thing's going to happen with cosine. Cosine, our x here, our adjacent side is negative 7 over 5 radical 2. So we're going to have to rationalize that. I'm out of room. Okay, so we have negative 7 over 5 radical 2. Multiply the top and bottom by radical 2. The bottom becomes 10. We already saw that. And then we just get negative 7 radical 2. So that's how we're going to write our answer. Then for secant, it's hypotenuse over adjacent. So it's going to be negative 5 radical 2 over 7. Okay. Tangent is opposite over adjacent, so 1 over negative 7. And then cotangent is the reciprocal. So this is just going to be negative 7. There we go. Cool. All right. Last one, you're going to go, Barton, please. No, not another one. Don't worry. This one's pretty easy. This one's like a special case, and you don't actually have to do any of the Pythagorean theorem stuff. So we're looking at this angle here, but we need to remember sine is y, cosine is x. So here, we don't have an angle, right? Like there's no angle because it's just straight down. So the way we want to do this one is cosine is just your x. So because we have gone 0 in the x direction, cosine is 0, and then sine is the negative 6. Cosecant is 1 over this, so it's 1 over negative 6. Secant would be 1 over this. You flip this. You can't have over 0. So secant is undefined. Okay. Likewise, tangent is y over x. Because our x is 0, you can't have that. So tangent's also undefined. All right, because it would be negative 6 over 0. And then cotangent is the reciprocal of this. So it would be 0 over negative 6, which is just 0. So if you get one of these, the like north, south, east, west directions, or the 0, 90, 180, 270, those ones, 2 of them will be undefined and 2 of them will be 0. The other one will be whatever the non-zero number is, and it's reciprocal. Okay, cool. All right, so there's finding weird trig functions if you're not looking at a unit. That's fine. Let's talk about inverse trig functions. Let me start with an analogy to help you kind of understand what math you're trying to do, and then we'll go do a couple of easy examples. Okay, so every trig function has an inverse the same way multiplication has division and adding has subtraction, right? So whatever math operation you're doing, there should be an opposite math operation or like an undo button. So trig functions have an undo button, and what we do with trig functions is we plug angles into them to get ratios of sides. So if I give you a ratio of sides, there should be like an undo button to go back and figure out what the angle is. So the purpose of an inverse trig function, you use the inverse trig function to get the angle, or to take the trig off of the angle and get the angle by itself. But let me make an analogy really quick, and then we'll talk about this. So if you have x squared equals 4, how do you undo the squared? And now you all mumble to yourself, square root, I know that one. All right, very good. You do a square root. Okay. Notice that you didn't say to yourself, divide by 2. And maybe 4 is a bad example here because that's the same answer. But you can't divide by 2, right? You don't divide by the number you see. You do a different math operation. You do a square root. Okay, cool. Let's talk about this. If you see a sign, there's no such thing as divide by the sine function. That's like saying divide by the subtraction symbol, or divide by the division symbol. You can't divide by a math operation, okay? So you need to do the opposite of a sine function. Here is what you need to know. Cosine is not the opposite of sine. When people see sine, they go, oh, the inverse is cosine. No, those are just, they're two things that, they're like two different types of multiplying, okay? This is multiplying with opposite and hypotenuse. This is multiplying with adjacent hypotenuse. They're both doing the same thing though. You give them an angle, they give you a side ratio. We need the inverse of this thing. Unfortunately, there is no fancy name for the inverse of sine. It's just the inverse of sine. Okay. Another way you can write it, sometimes you'll see it on calculators this way, is arc sine. Either way, you need to do an inverse sine on both sides. So the inverse sine will cancel the sine, and then you'll get theta equals the inverse sine of 1/2. Now, how you do this is you either know the answer because of the unit circle, or you put it in a calculator. There's not like a fraction or radical or some like math function that I can give you here that will tell you this. You have to know this answer, right? You can't count it or anything like that, but you'll just use a calculator. It's not that big of a deal. Just the point is, solve for theta by doing the inverse sine function and then throw this thing to the calculator. Let's go look at some examples. All right. So if we look at this triangle, we want to know, what is theta? Theta equals question mark. What angle is this? How big is this? Okay. So what we want to do is we want to set up a trig function using the information we know. So the first step you want to do is label what sides these are relative to your angle. So this side is straight across from my theta, so this is the opposite side. This side is right next to it, and it's not the hypotenuse, so this must be my adjacent side. Now we think to ourselves, which trig function uses opposite and adjacent? Tangent. So we're going to write our tangent function. Sorry, this is just a little pudgy. So tangent of theta equals opposite over adjacent. Okay. So now we're going to simplify this just a tiny bit. Tangent of theta equals 2. Now we need to get rid of the tangent and isolate the theta. The way we do that is with an inverse tangent. So we're going to do inverse tangent, which is tangent and a little -1 power there. The inverse tangent cancels your tangent, and then we have theta equals the inverse tangent of 2. This thing we type into a calculator, and you're going to have to just hold on half a moment, type it in. Hopefully it gives you something nice. In this case, theta equals 63.43 degrees. Unless I give you really nice triangles, and I probably won't because I'm mean, then you're going to get ugly decimals like this. I'll make sure I put in the instructions for your homework how many to round to. It's probably going to be 2 decimal places. Okay. All right, let's try one more together. I'm going to erase this so you guys can see a little better. All right, so looking at this triangle, here it, why is that loading? Okay, it wants to load for some reason, but. So for this, first step is label your sides. This 8 is making up part of my angle, but it's not the hypotenuse. This is the hypotenuse right here. So that must make 8 the adjacent side. All right, now we want to set up a trig function that uses adjacent and hypotenuse. So the trig function that uses adjacent and hypotenuse is cosine. So we have cosine of theta equals 8 over 10. Cool. Reduce your fraction if possible. So cosine of theta equals 4 over 5. Now to get the theta by itself, we need to do the inverse trig function on both sides. So we're going to do inverse cosine, inverse cosine. The inverse cosine cancels the cosine and frees my boy theta. Then we have cosine inverse of 4 over 5. This thing goes in the calculator now. So we're going to do our inverse cosine of 4 over 5. And then it spits out a number that's eerily complementary to this one. So theta in this case equals 36.87 degrees. And there you go. That's how you do inverses. So not too bad. If you have questions on anything in this lesson, make sure you let me know. And I'd be glad to go over them again. Maybe like and subscribe. It makes me feel good about myself. I'll see you guys later.